Let's get back to work. Module 2, Session 2.2. In this session, we are going to discuss 555 timer circuits, which forms part of Subject Outcome 2.2 on non-sinusoidal oscillators. The 555 timer is the most commonly used waveform generator in electronic circuits. It is an extremely versatile, affordable, and accurate timing IC. It acts as both a source and sink of current, as we will see in a moment. The 555 timer chip contains input and output pins, as we'll see shortly. The standard 555 timer contains 8 pins, but similar devices have been made which contain more pins. This device is a 555 timer, but it doesn't tell time or create time delays. Rather, it measures the time it takes a capacitor to fill up. It does this by monitoring the voltage across the capacitor through the threshold pin, pin 7. It can measure in the range of a few microseconds to several hours. The 555 timer can operate in 3 modes by connecting it in a specific way for each mode. The time period of a 555 timer is controlled using an external RC network. Before exploring the different modes, explain to your learners what each of the pins does and how each one is connected. Pin 1 is 0 volts, so connected to ground. Pin 2 is the trigger. It gets connected low to start timing. Pin 3 is the output, so it gets connected to the device you're trying to control or time with a timer, for example, an LED or speaker. Pin 4 is the reset pin. It's used to reset the timing interval. When it's connected to ground, in other words connected low, it will reset the chip's timing back to the start. For most of our purposes, it should be connected high, in other words to the source, so it doesn't reset. Pin 5 is the control access for the internal voltage divider, but this pin is not used often in this course. Pin 6 is the threshold. It measures the time delay by monitoring the voltage across a capacitor. As a capacitor is filled up, it gets exponentially harder to fill. Once the voltage measures about 63% of the supply voltage, the timer will stop timing. This point is chosen because it is considered the straightest and thus most predictable part of the filling cycle graph. We'll see how this works a bit later. Pin 7 is the discharge pin. It's an open collector output that is used by the chip to empty the capacitor once it is full. It is in phase with output. Pin 8 is power, so it must be connected to a positive supply voltage, usually between 3 and 16 volts. Your students should understand the standard internal components and systems in a 555 timer. Explain that it contains resistors which divide the voltage between the power supply and ground. It contains a discharge transistor for emptying the external capacitor and thus restarting the timing. A 555 timer uses 2 comparators. Remember that a comparator is a device which compares 2 input voltages and then produces an output in the form of a digital signal to show which input is larger. It also contains a flip-flop or latch and an output stage. Explain to learners that when we represent a 555 timer in a circuit diagram, the order of the pins is drawn a bit differently to the actual layout of the IC. This is done to make it easier to recognize the functions of the pins. A 555 timer connected in ASTABLE mode has no stable states and thus constantly switches between states. This creates a repetitive pulse that is controlled by the RC time constants. When a 555 timer is connected in ASTABLE mode, pin 2, the trigger pin, must be connected to pin 6, the discharge pin. It must also be connected to the capacitor. This means that when the capacitor discharges, the chip will trigger itself and restart the timing. If you're not sure which mode a 555 timer is connected in, check what pin 2 is connected to. An ASTABLE mode 555 timer is ideal for applications requiring pulse generation. A 555 timer in ASTABLE mode will flip constantly between states. When the chip is sinking current, the LED 1 will light up. The capacitor will charge in this state. Once the capacitor is full, it will discharge and trigger the 555 timer to start timing again. The chip will source current and LED 2 will turn on. The time delay on the circuit can be increased by either increasing the resistor, thus taking longer to fill the capacitor, or it can be increased by increasing the size of the capacitor, thus the capacitor will require more charge to fill it and thus take longer to fill. A 555 timer in monostable mode will produce a single pulse because it only contains one stable state. In order to set a timer up in monostable mode, pin 2, the trigger pin, must always be connected to a switch so that it can be used to trigger the timer. If you want to know which mode a 555 timer is in, look for a switch on pin 2. Pin 6 and 7 should be connected to one another in this mode. The properties of a 555 timer in monostable mode make it ideal for applications that require a time delay. The 555 timer chip can act as an electricity source or a sink. When timer is initially triggered, LED 1 will turn on because the circuit is sourcing current and filling the capacitor. Remember that an LED is a diode and thus only flows in one direction. Also, current takes the path of least resistance, thus flows back into the output pin. Once the capacitor is full, the circuit will discharge the capacitor. The circuit will then act as a source with current flowing through it and to LED 2. Because this is monostable, we'll need to press the switch again if we want to trigger it. The time delay on the circuit can be increased in the same way as it was for astable mode, thus either by increasing the resistor or by increasing the size of the capacitor. We are now going to watch a short video showing how a 555 timer has been used in an astable multivibrator circuit.
This circuit represents an integrated circuit. Here's an integrated circuit. In this case, it's the 555 multi-purpose integrated circuit. In this configuration, it is constructed as an astable multivibrator, which is part of an oscillator family of circuits. You get monostable, bistable, astable. You also get Colpitts, you get Hartleys. Oscillators are circuits that switch themselves on and off. Later on, you will learn about a circuit called a flip-flop. The flip-flop circuit, RS flip-flop, JK flip-flop, are used primarily for memory. We all know about RAM and ROM, etc. These circuits are integral to the formation of memory. So this is just an example of an astable multivibrator using an integrated circuit. Inside this integrated circuit, there are 22 transistors, very much like the ones that you've seen before. There are 22 of these inside here. There are 2 diodes inside here, and there's about 2 or 3 resistors inside here. So you can see how integrated circuits have made construction of circuitry in modern day equipment easy, and that is why miniaturization of equipment has become possible.
We will now do a practical activity in which we will build a 555 astable multivibrator on a breadboard. Your facilitator will hand out the necessary components. Please refer to your workbook for the instructions. End of Module 2.